Okay, let's get started. So, are there any questions? Yes.
So, how do you explain the storage of negative numbers?
Okay, so what was mentioned was this 2's complement thing, so you don't need to worry about that. So all you need to know about signed integers is that 1 bit of the number itself is used to designate whether the number is signed or is positive or negative. So like a signed integer, signed int, for example, has 32 bits normally. So one of the bits is designed to say, is this number the positive version or the negative version? And then the other 31 are for the actual number itself. So then we could, using that 1 bit, determine, well, is this number actually positive or negative? So there's this thing called 2's complement. You don't need to know anything about that. Just know that 1 bit is for either whether it's positive or negative. If it was unsigned, then no bits are designed to signify whether it's positive or negative because it's always at least 0. So does that answer your question? Okay. Yeah.
What was the question?
So it was how does the signed bit relate to the representation of a signed number? So yeah, so it's like how does it actually store that 1 bit? Yeah.
I guess the question was more, will we on a test be asked to write a negative number in binary?
I never thought about that, but that's a good question. Now everyone in the room except you hates you.
No, but then you would need to know how to express it.
You would just, to like literally write it down? So it doesn't actually really matter. But you can just say, for example, the very first bit, that is the signed bit, for example. But if I was to ask this on a test, I probably won't because everyone will hate me. But if I did, then I'll actually say, if the negative is required, put it as the first bit. I'll actually give you the exact way to represent it. Yeah.
So you're saying the first number, like an 8-bit sequence, would be
1 then followed by 7 digits for the actual number itself. Yeah. Other questions? Any questions about the test itself, which is, when is it? Friday, good. Any questions about the test itself? So I uploaded the review. So I'm not including everything on chapter 4, I've decided. But any questions about the test? Yeah.
So what are you not including on chapter 4?
So some of the things I'm not including are the switch statement, which we'll probably get to today, and enums, as well as menu-driven program. Oh, no, that's on here. So mainly switch and enums. So switch we'll get to today, enums probably on Wednesday. They're in the chapter 4 slides, though. Any other questions? Yeah. So I think we did everything in here except menu-driven programs. But yeah, so this is not going to be very much, if any. So yeah, we pretty much have covered everything by now. Yeah.
Can you give an example of like a logical operation here?
So remember the logical operators. So logical operators are, where are they? Yeah, so logical operators are just a way of working with two or more conditions that I need to handle at the same time. So if I want a condition to be true, which is this condition and this other condition to both be true, then I can use that using 2 ampersands. If I wanted that one condition is true or some other condition is true, either one of them to be true, then I would use OR here. So that's actually a good thing to consider. So let's say that we want to have a user enter a command to us. And we're going to have them enter a single character. So let's say that we do something like this. Where we have a character, we print out enter command, the user enters 1 character. Well, let's say that we wanted to do something like on assignment 3, where we asked the user, are you going to actually order anything else? And then we would have to check whether the user entered some character y, for instance, to signify yes. Well, the user could enter capital Y or lowercase y, right? So how would I write that here? Like if the user's entered character is capital Y or lowercase y. So how would I actually do that? Use the double vertical bar to signify or, the logical operator or. Well, what are my conditions? Is it what's sorry? Well, we already did, but I want to now check after the user entered it whether it actually equals some value. So the user's entered it right here. So now I got to check, is it actually equal to capital Y or lowercase y? So how would I actually check that? Well, I'm not actually doing a check here. Yeah.
You have an if statement that has a capital Y, but has a character or lowercase y.
So are you saying this?
Yes.
So the condition's always true, though. Yeah. If C is equal to Y. Well, what if I did this? So what is this actually doing? Assignment. So what am I wanting to do instead? Check equality. And how do I do that? Double equal. Good. So if I do this, then we can see out entered y or little y. Then what if I put else here? What does that signify? Yeah.
How do you input those lines? Where is it on the keyboard?
So it's shift how do you say it? Backslash. So where the backslash is, shift there. So on my keyboard is right below where the backspace or delete key is. Yeah. So what does this else signify? If we enter this else curly braces right here, what happened? They entered any other character. So maybe we can say invalid input as an example. So let's just say that we entered capital Y, then we expect to enter the first block, and in fact we do. If we in fact enter lowercase y, then are we going to still enter the same block? Yeah, so we're going to still enter the same one because we have or here. So, yeah, so here's actually a good question. What if I did, by accident, I put and there? Before I hover over what's highlighted there, what do you think it's going to say? Yeah, the condition is always false, right? The logical operation is expression is always false. Why is that? Well, could a character be equal to some value and another value simultaneously? No. So that's why it's always false. So here, we actually do need an or here. So if I do enter something else, then it'll say the other result. Okay? Any questions on the logical operators and how they work? Yeah. Yeah, of course. So I can do like or C equals capital N or C equals little n. Little n. Yeah, so I could change these if I want. But the switch statement that we'll probably get to today will help mitigate against this type of thing where I just say it's equal to this or equal to this or equal to this or. So the if condition can be very long. So there's a way of actually making it a lot simpler to work with, and that's the switch statement. But any questions on, yeah? So exclusive or, so let's write this out because I can't immediately think it off the top of my head. So what does exclusive OR mean? I can't have both. So let's just say that we have condition 1 is X, condition 2 is Y, and our goal is to do X, X or Y. I guess I should use like A and B because I don't want to say X, XOR. So A, XOR B. So remember A, XOR B is A or B, but not both. Could I rearrange this to say A or B and not both? Could I say that? Oh, yeah, I'll use parentheses. But is this the right way of thinking about XOR? A or B, and it's also true that you can't have both. Yeah, okay, well, let's see. How do I write A or B in C++? Yeah, the 2 lines, just like before. Yeah, A or B. Ignore the first part now. How do I just write both by itself? And, the double ampersand, right. So A ampersand, double ampersand B. But it says not here. So how do I signify not for a logical operator? Well, let's go back to the slides. What is not? Exclamation mark. All right, so exclamation mark. So if I put it right here, is that what I want? No, what is this saying? It's not A and B, but I want the result of not of A and B. Okay, so how do I say not of A and B? Parentheses. Good. Excellent. Okay, so we handled not both, as well as A or B. How do I handle the and in the middle? And, double ampersand. So could I do something like this? Because here's the first condition, then the second condition. I think it actually will work, but I'm not completely sure, so let's try to force it to work. What would I need to do? So that is something different, which is bitwise and. This is logical and. So remember, bitwise and is on the binary representation of the integers, right? Here is on whether something's true or false or not. You actually could do that here, but let's try to make it so that it actually is a logical operator, not a bitwise one. But how do I force this to make it more clear that I know what I'm doing? Put parentheses around A or B. Good. So I do this. So A or B and not A and B. So it's the case that one of them must be true, and it's also the case that it can't be both of them to be true either. So it's exclusive. Exactly one of the two is in fact true. Yeah. You mean like if I wanted to print this out? Yeah, but this is exclusive OR. So that would be, so the trouble with that analogy is that every student has exactly one grade. So it's not like it could hold 2 different values. Well, let's actually put it back in our example of this one, where we have, so let's just say that so the problem with this one is that the user can only enter one character. They can't enter 2 different characters. So all this really is comparing 2 different conditions together. You require that one of them be true and the other one to be false. So what could happen is, let's say that your computer is, you're trying to upload, let's say your submission file to Blackboard, okay? Let's say that your computer is doing that. Well, if you look up how your computer actually sends information over the network, it sends it to your router, and then that router forwards it to another router, another router, another router, and then eventually it finds its way to Arizona State University's servers. Okay, it finds some way. But as you might imagine, there are multiple ways of choosing the next router along the way. So if you're not careful, it could be that you upload more than you need to, in the sense that you're uploading the file via one direction, and then your computer also does it via another direction. Well, a use for XOR here would be on the server to say, I'm going to only accept the connection from one of these paths. I'm not going to accept it from another one. So therefore, you'll be guaranteed to get exactly one copy of the file. You won't get additional copies. So that would be an application of why you would want an XOR like this. Cool. Other questions? Yeah.
Actually, one good example of that is a light switch.
Yeah.
And then I actually have a question. Are all of the logical operators in the same precedence that are just evaluated from left to right?
Great question. What is the precedence? So the highest precedence is not first, then and, then or. So in fact, going back to our example, if I omitted it like this, the parentheses on the first part, it will evaluate exactly the same way. It's harder to read, but it's still the same. Why? Well, parentheses always take precedence over anything else. So parentheses will be evaluated first. So therefore, there's only one operator in here, the AND operator. So that's evaluated. Then over here, not takes highest precedence. It's evaluated first. Then AND is evaluated next. Then the OR here. But if instead I had and or like this, then I actually would need parentheses. Actually, would I? No, in this case, I wouldn't. No, I'm just saying if I did something like this. But here, it would still evaluate correctly. So I always recommend put parentheses around everything, just to be absolutely sure that you are evaluating things in the right order. But there is a precedence here just in case you happen to not do that. Any other? Yeah.
What's the precedence for the
There were slides about this. Let's see. Do I have them open? No. So let's look at the bitwise ones. Oh, I don't have them. I think it's the same. So the corresponding not, the tilde, that is first, I think, then ampersand, then or. I think it's the same, but please check this for yourself. So don't blindly trust me on some of these, because as you know, I'm wrong on some of these things. So check for yourself if you're not completely certain. Because in fact, I actually don't know, but I'm going to conjecture it's the same analogous type precedence as is in here. Any other questions? So who is having trouble with assignment 2? So any questions about assignment 2? Yeah. Mm-hmm. So this one I highly recommend that you try it out for yourself, but to see like what do some of the values do. Well, think about what's happening here. I'm repeatedly doing an OR with the current value so far, with shifting what it was before. So I shift it, then I OR it with whatever it was before. Then remember, what happens with the OR operator? So if I have 0 and 0, what is the OR of 0 and 0? 0. In every other case, what is the OR of something and something else? If one of them is a 1, is a 1. So what do you think is very likely to happen at the end of the OR statements here? There's going to be a lot of 1s, right? Then you have to think, well, what does the plus 1 at the end do? So I encourage you to think about what actually happens there. But think, there's going to be a lot of 1s, and I add a 1, then think about what happens. Other questions about assignment 2? Yeah. This one? Yeah, so remember, please check the announcements. I made an item about this. So you can accept either negative or the logical operator, the exclamation mark. So we'll accept either submission. That was my fault. I meant it to be an exclamation mark. But yeah, yeah. Well, isn't that what the entire question is?
I'm just confused on the X and X-1.
Yeah. So can anyone tell me? I know, but can anyone tell me what this ampersand thing is? Oh, what's sorry? Yeah, it's doing something with the binary, but what is it giving me back? Yeah. Exactly. So let's say that we have these numbers. Let's see. Let's say we have these two numbers, and we wanted to do this operator and of them. So what should be my result? So I'm looking at the 1 here and the 0 at the beginning. So what should be the final bit for that position? I heard a 1 and 0. I'm doing an and here. So what should it be? 0. Think of and as doing multiplication. So what is 1 times 0? 0. 0 times 1 is 0 again. 0 times 0, of course, is 0. 1 times 1, 1. 0 times 1 we saw is 0. 1 times 1 is? Good. So what this is it's taking the binary number of x, and then as well as the 1 for x minus 1, doing this and whatever it does, and then checks whether the resulting number at the end is 0. So is this number at the end 0? No. So in fact, this number at the beginning is not this second number plus 1, so it's kind of moot. Well, what if I did 1, 0, 0, 1, 0, 0, like this? So I subtract 1 from the top number to get there. Well, I'm going to get 1, 0, 0, 1, 0, 0, if you just check the positions. Well, is this final number 0? No, because there's a 1 in there. So think. So this is kind of a big hint, but think about when f is true. So think, well, if f is true, then this computation, whatever it is, has to be equal to 0, right? So that's what it has to be. Well, what has to happen for x to allow this to be 0? So think, well, therefore x and x minus 1 can't have a 1 in the same position, right? So therefore, because if it did, then the number is in fact not 0. So think, when does x and x minus 1 not have a 1 in the same place? Okay, so that's what I want you to think about. So the whole goal of this assignment is to think, well, try to work backwards. So if we print true here, then how did that true occur? And then why is it true that that occurred instead of just trying values? Trying values is okay, but you have to be able to understand why something works. Or for this one, for this to be true, then obviously the result within the parentheses, not the exclamation mark, has to be false. So when is this inner expression false? So that's what I want you to be able to think about. Okay? Any other questions about assignment 2? Programming 1, pretty straightforward? I hope it's pretty straightforward. Okay, any questions about assignment 3? We get to go to eat at In-N-Out now. So I hope you like In-N-Out as much as I do. So you'll be basically making a program that, so their servers are down and you miraculously arrive to In-N-Out and they see you, hey, we saw you that a new hire at Insanely Great Shapes. We want you to make a C++ program for us. So in the few minutes that you are able to, can you actually make a program to solve their problem? That sort of thing. So yeah. So any questions on this assignment? Yeah. Lab 3? Okay. I didn't hear you.
Lab 3.
Mm-hmm.
Lab 3 is part of the grade. Is that the same thing that I can ask you about?
Lab 3 is part of the grade, I'm not sure.
I look at lab 3.
Okay, yeah.
Is that kind of what I was asking?
You mean, is this like the actual grade distribution of this class? Or what is he asking? I'm not sure. No. So remember, each student can only have one grade. So it can't be the case that the student can get both an A+ and an A. So these are exclusive conditions. It seems like you could use XOR here, but what is a better idea? If and else if, then else if. So last time we saw, I even mentioned this at the top, where we looked at the user's entered grade, and then we checked, is it above 90? Then we print A. Then otherwise, else, if it's at least 80, then we print B. Else, if it's at least 70, print C. Yeah, so that's the goal of this one. Yeah, so there's, yeah, you probably won't be using XOR in this class, but I'll try to think of an example. What's that? It's not here, though. You're not using the XOR operator here. Yeah, you're using if and else if. It's not the same thing. Other questions? Yeah.
I have a question on problem 3 in assignment 2.
Okay.
So since it says that the cylinders are...
Oh, this one, yeah.
Yeah. So since the cylinders are infinite distance in the y direction, how come we still
In the z direction. So it's a plane where players are moving. So think like you're looking down at the plane, and you just, to your perspective, you see circles. And then you just see, are these circles intersecting? So the question is significantly harder if the cylinders have finite height. So if one of them is 5 meters tall and one is 10 meters tall and one is off the plane, then the condition of whether they intersect actually could be an exam question, a good one. But I'm kidding. But yeah, it's only in the 2D perspective here. What's that? Yeah, you're essentially saying whether the circles intersect or not. Yeah, or are tangential. Yeah, so problem 3 should be very straightforward, very short. But any questions otherwise? Okay, so let's get back into the material if there are no other questions. Okay, so we've been talking about decisions for a few classes now. So we first saw relational operators, relational expressions, which are comparing one value against another. Is some value at least another, as large as another value, or are they the same, are they different, that sort of thing. Then we saw the if statement, the first non-trivial part of C++, where we said if some condition evaluates to true, then we execute some code. And then if the condition was not true, then we don't execute that code. And then we saw some examples of this, some flags we ran into, which is essentially the same thing. Then we saw if and else. So in that example where I said condition is false, we don't execute the code. Well, maybe we do want to execute some other code in the case that the condition was false. So if the condition here is true, we execute some statements, and false. If it is false, then we execute some other ones. So as an example, if we have score at least 60, then we print pass. Otherwise, then we want to execute you did not pass. If I did not include the else there, then I will always print you did not pass, because even if the condition for if was not true, I'll still come down to that. But if I did put else there, then now it's dependent on whether the condition is true or not. Okay, so some other ones. We discovered if-else chains, which are if we have an if statement, then we have an else, but we need to consider some other condition as well. Then else, some other condition, else, some other condition, and then finally some else optionally at the bottom. So where did we actually see this in if-else chain as an example? Was there? How about the grade letter grade calculator we saw, where we if the score was at least 90, we printed an A. Else, now we needed to check whether it's between 80 and 90. So we had the additional if, checking whether it's at least 80 as well. Then we printed B. Else, if it's at least 70, we print C. Else, if it's at least 60, we print a D. And then a final else with no if check, because we don't need to check anything else at this point. We print E or whatever for that. So the trailing else here is essentially a catch-all scenario. So if none of the ifs up here ever succeed, then the final else will catch that for us. If we didn't have this else at the bottom, then some conditions may allow it to go all through the conditions and never execute anything in the if statements. So the else is just a catch-all scenario. But of course, we can have nested if statements. So if I have an if statement, I can put any code I want, including if statements inside of there. Okay. So then I'll come back to menu in a second. So we saw logical operators, which are a way of working with multiple conditions simultaneously. So we saw some examples of this. Yeah. So I think we were almost here, but I'll come back to menus in a bit. So one optimization of C++, which is kind of nice, is if you have an AND operator, so I have to check two different conditions, if it's the case that you evaluate one of them to be false, do I need to evaluate the other one? No, because the false and anything is false. Correspondingly, if we have an OR and one of them evaluates to true, then there's no reason to ever check the other one, right? Because true or something else is always true. So what's the downside of this? So why would this be a bad thing? There's a definite advantage that you're executing less code, but what is the downside? So we haven't really talked about this yet, but suppose that one of the conditions does say user checking whether a user is privileged enough, in the sense that the user has access to the system. So for example, when you run code on this machine, are you just a normal user, or are you what is called root of the system? So different abilities to access different parts of the computer. So what if you had a check where it says, okay, did the user enter the right password, and is the user did the user enter the right password, or is the user the root user? Well, if the user entered the right password, then that condition will evaluate to true. But since I have an or here, then the condition of whether or not the user can be the root user, that will never be checked because of this short circuit evaluation type thing. So just be careful that some things will be executed and some things may not be executed. What was I going to say? This is another thing that I don't like about these slides, but I'm just using what the book says to be consistent. It says that if an expression using the whatever operator is being evaluated and the sub-expression on the left side is false, does it have to be on the left side? What if I evaluated the right side for an or, for example, and it evaluated to true? Should I skip the left one as well? Or do I have to do left then right? Well, let's see. If I have A or B, is that the same truth value as B or A? I have a yes and a no. What is one way we can validate this? Let's try it. So let's put this down here. So I'm going to do 4 different commands. So true or true. Let's see. So let's say bool A is true, bool B is false. So let's see out A and B as an example. And then we'll do B and A. I don't know why it's complaining to me. I'm not sure why that has an issue. I'll investigate that further. Oh, okay. So here is an example, I think, where you need to put parentheses around the expression in order for it to evaluate correctly. There's a deep reason why it didn't work, but let's look at the output. So in fact, it said it's the same here. So in fact, it doesn't matter what order you execute an and here. So the short circuit evaluation, in fact, the official standard of C++ says there's no guarantee of whether one will be executed before the other. What the compiler will do is we'll try to optimize it as much as possible to try to heuristically say, okay, it appears to me that this code, that you have in this expression, is much faster to evaluate than this other code over here. So then what it'll try to do in a short circuit evaluation sense is it'll try to execute the faster seeming code first before it'll do the slower code second. So, but it may do something completely different. You have no guarantee on what will actually happen. So just take this as a little red herring here. We won't encounter that sort of thing, but just try to think of this if you try to use C++ in industry. Sometimes the thing on the right will be executed first before the left. Yeah. Yeah, so that's actually a question that could take years to explain. So the question was, how does the compiler actually know that? Sometimes what the compiler can do is, even if you write a whole bunch of code, it could optimize it all away. So if I have a really long calculation, if it can figure out what that calculation is before the program even runs, it'll just substitute the correct value everywhere. So there's a lot of techniques in compiler optimization that I can't really get into because it's just too much. But just note that you can't necessarily guarantee what things will be executed in what order if you have an AND operator like this. If you have things in sequential order, like line, then line, then line, then line, then that will be executed in order, although that's not true either. So just be careful on grandiose statements like this. That's all I'm saying. Other questions? Okay, so we saw today, I guess, precedents for operators. The not is first, then ands, then or. But always put parentheses to make it clearer to read. This is essentially the same thing. So here's an example. So if we wanted to check whether a grade is valid or not, then one thing you can do is to check whether if it's between 0 and at most 100. I disagree that if a grade is more than 100, it's invalid. But definitely if it's less than 0, then that's invalid. So, of course, if we have some other condition, we need to be able to check that. So I want to show you a really cool function that I remembered, and it's called clamp. So one issue about whether you have a range or not, being able to work with like a short or something, is that it has a short range. No pun intended. But it has a short range of integers it could represent. Well, if I have a large integer, then maybe what I want to do is I want to clamp the large integers down into this range. So maybe, for example, for like a valid grade range, if you have something that's more than 100, then maybe you want to just, for clarity or ease of use reasons, you may want to clamp that down to 100. Or maybe if a grade is below 0, then you can clamp it down up into 0. So the use of this is, this example is a little verbose, but we can try to look at it. Don't worry about these two lines up here. That just sets up what is called a random number generator. Then what happens here is I get a random number. So V you could think of as a random number. So if I wanted to clamp it down to 8 bits, then I may have to do some calculation as to say, if it's above what the maximum for 8 bits, then I'll set it to be the maximum. If it's below the minimum, I set it to be the minimum. But one way we can do this really easily is with a function called clamp. So I highly recommend you to use this, especially for some assignments like if you wanted to do that grade range thing, if you wanted to clamp the number of points we get in the class down to 1,000, and if you happen to have more than 1,000, you can actually do this with clamp. So I highly recommend a function like this to use. Okay, so let's go back to the menu slide. So the lab 3 and assignment 3 are designed so that you can be able to handle something like a menu. So we're going to go into more detail about this when we get into the loops slides. But for now, all this really is you present a menu to a user of options that they can select, and then you just wait for them to enter some command. So they could enter, for example, Y, I'm going to order more things at In-N-Out. And then when you get that input, you say, oh, if this input is equal to Y, then I'll handle the code about ordering more things. If they entered something else, then maybe we'll handle some other code. If they entered even something else, we'll handle something else. So being able to handle user input is actually very important. But going off of that, you may want to actually check for valid user input. You can't always assume that the user is competent or knows what they're doing or is not evil. So the user can try to be malicious or not and try to screw up your program. And by doing that, they could enter some bogus input that the program has no choice but to accept and try to run on. And then if they understand your program, then they can cause your program to do unintended behavior, maybe malicious behavior. So input validation is a huge problem in security. So if I want to absolutely check whether some input was completely valid, that is something that's hard to do. in general. But some things you can try doing are checking whether it's actually in the range or not. So what is a problem with checking whether something's in a range? Remember when we had that example where we set a number that was too large to fit in the range? Right? So we put a number that's too large into like a short or something. Then what happened? And we tried to print it out. What actually printed out? The truncated part. But that part, since it's truncated, fits within the range. So therefore, if I'm doing a range check here, then in fact, I may get something that's in the range, but originally it was not. So I may cause unintended behavior that way. Valid menu choices. So a valid menu choice would be if the user enters option A, B, C, D, or E, and let's say that those are the only 5 options. What if they enter like F or something? Then what should I say to the user? I need to be able to handle that and say, yeah, you entered an invalid input, try again. And then we would ask the user again, hey, can you enter another one for me? And then we'll just repeatedly check over and over using a loop, which we'll see probably next week. We'll keep going until the user enters something valid. Okay? So we're forcing the user to actually enter something valid here. Checking whether you're dividing by 0, which could cause the program to crash. Things like that. So user input validation is extremely important. So that's why the trailing else in the if-else chain, remember that last else, which is the catch-all case, that is to handle any potential invalid input via the user. Okay, so this one is not as important, but the scope of a variable is just where it's defined. So, and I kind of mentioned this before. So, okay, it's best to have an example. So, I'm going to show you code, but please, please don't do this. Okay? So, I'm telling you something. I'm showing you an example that I tell you, please don't do this. So, let's say we do something like this. Maybe this won't work. Maybe this will work. Let's see. Well, let's see. Let's say that I copy. So this program obviously prints 10. But what if I did this? What do you think the error is before I hover over it? Yeah. I'm redefining the value, right? So I'm redeclaring x to be an integer. It says redefinition of x. But why doesn't it say it here? Yeah.
Because it's inside of the scope.
Right. So scope is a huge issue in programming, where, okay, so let's say I did this. So maybe I did something like this. I make a bogus if statement. It's always going to evaluate to true. What if I try to print x out here? It says that use of undeclared identifier x. What went wrong? Well, I'm declaring this integer inside this different scope. Okay? So I said that whenever you define a variable x, it could be used anywhere from that declaration downwards, but that's not completely true. You can use it anywhere downwards in the same scope. So the scope of this variable x here is between the curly brackets. So it starts up here. You can print x inside the curly brackets. As long as you're in there, you can always print. But once I leave that scope, then I can't use that variable anymore. Yeah? Yeah, we'll talk about deallocation and things like that. But you're right, it's deallocated once you get out of that scope. Yeah, so just be careful about scope here. Some languages allow you to have scope like this. Some, like C++, don't. Any last questions? Hold on. You have a quiz right here. So please get your quiz. It has your name on it. They're alphabetically ordered. And return them on Wednesday.
I have another question. So your link goes to this page for tutoring centers, but which one is it?
Oh, good question. CSE, sorry.
Okay, thank you.
Yeah. Yeah, so the names are on top, so you'll hear here by last name. Please only take your own.
Pull up that random number generator thing again.
Yeah, we haven't really talked about number generators, but it's just the example that they happen to have. But this is the correct way to make a random number. As you'll see in the quiz, there's another way to make random number, but it's not perfect.
Yeah. So is the quiz just due on Wednesday?
Yeah, at the start of class Wednesday. Yeah, please take your quiz and get out of the way for everyone else to pick their quiz up. Please only take your quiz. It has your name and posting ID on it.